Questions 21 through 25 of the 2001 Grade 11 Fermat Math Contest. A spiral of numbers is created as shown, starting with 1. If the pattern of spiral continues, in what configuration will the numbers 399, 400, and 401 appear? So the answer choices, they've given you some configurations. All right, let's write this out. 1, 2, 3. I see it's going around. Okay, I got it. So let's use what they've already given us until 22. All right, so they've already given us until 22, so let's just keep going with that. So we got 23, 24, 25, 26. And then once we get up to 26, we're going to start going right, 27, 28, like that. And then once we get to 31, we'll start going down. And once we get to 37, we will start going left. And then just keep on going like that, round and round, basically. And I hope to find some sort of a pattern, but so far I can't see anything really, to be honest with you. So I'll keep going, just a couple more, and maybe I'll find something. All right. So here we go. Keep going here. And they want us to keep going until what number? 400. 399, 400, 401. Oh boy. So I'm certainly not going to keep going until 400. And you don't have that much time on a math contest anyways. All right, so what do we have here? Do we have any kind of a pattern, that always is going to be the same? Very similar to that units digit question that I did on the previous video. Let's see here. 1 is the starting point, correct? Right here. And let's see. Look at the diagonals here. Okay, so I'm looking at the diagonals. I saw something here. I got 4 here, right? And 16 here, 36 there, 64 there. You know what? It's worth it. It's worth it to just draw a few more just to see what I'd get. I'll do it really quickly. 85, 86, 87, 88, 89, 90, 91, and 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, and then I'd start going that way, 103. Okay, good. 100. All right, so 4 is 2 squared. 16 is 4 squared. 36 is 6 squared. 64 is 8 squared. And 100 is 10 squared. Okay. That looks like a pattern I can work with. So they want us to get up to 400, right? So that would mean 400 is what? Is 20 squared? Yeah. Okay. So 400 would basically be in this kind of diagonal. So if you had 400 ... it'll be like this, right? And therefore you'll have a number above it, 399, and you'll have a number below it, 401, because each of these has a number above and below, right? Because 100 has a number above and below, 99 and 101. 64 has a number above and below, 63 and 65. 36 has a number above and below, and you get the point. So this is the orientation, 400, and it'll be going down, right? Like that, because that's how this is going. Okay, so 399, 400, and 401. Which one of those? I hope one of those looks like that. 21. This one. D. D looks like that. So great, we got it. So the importance of finding patterns on math contests is very important, as you can see. All right, this question is number 22. I'm going to solve it for you, but it's going to have just a slightly different number, but don't worry, the question is exactly the same. A sealed bottle which contains water has been constructed by attaching a cylinder of radius 1 to a cylinder of radius 3 centimeters as shown in figure A. When the bottle is right side up, the height of the water inside is 20 centimeters, as shown in the cross section of the bottle in figure B. When the bottle is upside down, the height of the liquid is 28 centimeters, as shown in figure C. What is the total height in centimeters of the bottle? Okay. All right, so here we go. Where do we start? Well, I think the first thing we can do is first figure out what is it that they're trying us to solve. So what I've done is I've drawn a little bit of a diagram on the side there, and I'll just label it very briefly. This part here, from here to here, I will call H, big H. And this part from here, top to bottom, I will call little h. What they want us to figure out is the total height. So they want us to find big H plus little h. All right? That is what they want us to find in the question. And therefore, we can proceed from there. Now I'm going to blow this up a little bit here, just so that you get an understanding. And then I can always bring it back down. I just don't want you to have to squint to see what I have to write here. Now I'm going to label these, so you're going to have to just bear with me. From here to here is H, and we already labeled that, big H. Okay? From here to here is small h, right there. And then this little guy in here, right here, this little guy right there, I hope you can see it in red, that I'm going to call X. Okay? Because this 20 all the way from top to bottom is not from there to there. I almost missed that because, you know, if you don't look closely enough, you think, oh yeah, that's just this H. No, no, no. It's from the bottom all the way to the top right there. Okay? So really quickly, that 20 is basically H plus X. Okay? And then I also have to label one more, which is right here. That. So that is H minus X. Okay? And in a very similar way, I'm going to label the other one. Let's see what we have here. From here to here, it's the same. You're just flipping it upside down. So that is going to be H from all the way from there to there. This little guy up here, that distance right there, I'm going to label Y. Probably do it on the other side there. Y. And therefore, from here to here has to be H minus Y. And from here to here is small h. And I think that completes the labeling of the diagram. So I can squeeze this back down and fit in everything. All right, great. So now that we labeled our diagram, let's calculate the volumes. Figure B, figure C. Volume of figure B is pi r squared times height for the big part plus pi r squared times height for the little part. And what is the two parts? If you draw a line there, the big part is this one and the small part is that one. Basically, you break it up into two rectangles. So I hope you can see that. Maybe I'll blow it up a little bit. So basically, if you draw a line across, the big part is there and the small part is there. Okay? So let's solve for this here. So we have pi r. The big R they tell you is 3. So 3 squared. H, of course, we don't know yet. The little r is 1. So that's 1 square. And the small h we don't know yet. But we did label the small height x. See, it's right there. So I'll call that x. So this becomes 9 pi h plus pi x. All right. Now we get to figure C, sorry. We just did figure B. So now the volume of figure C. Very similar. Again, you're going to cut it into 2 parts, and that will allow us to figure out the volume. So pi r squared plus pi r little guy squared times h, like that. Pi r squared big H, pi r squared little h. So the big R is 3 again. And then we've got h, but in this case, be careful now. Our height is not that. Our height is from here to here, right? So it's h minus y. So don't get confused. Just look at the diagram very carefully. And then we got pi small r, which is 1. And h in this case is indeed the full small h, top to bottom. So there you go. That's the correct way of writing that one. So this becomes 9 pi h minus y plus pi h. And that's it. And I think that should be it, because this is the same as this, right? These figure B and figure C are the same. The only difference is that they're flipped upside down. So the amount of water in figure B is the same as the amount of water in figure C. So that means that VB is the same as VC. And we can now equate them. 9 pi h plus pi x is equal to 9 pi h minus y plus pi h. All right, so this is what we're going to use to figure out what we need. And before we do that, there's a couple things that, of course, are pretty obvious, and that is that the big H plus x, they've told you, right, is 20. And I think I mentioned that too earlier. I said be careful. Don't think that h is equal to 20. 20 is actually big H plus x. So I'm going to write that over here. 20 is equal to big H plus x. Any other relationships? Well, yeah, well, figure C has got to give us a relationships for 28, right? 28 equals something. It equals what? Our small h plus big H minus y, right? Yeah, exactly. All right, that's all the information we need to go ahead and figure this out. So we're going to proceed with this equation. So here we go. So we got 9 pi h plus pi x is equal to 9 pi h minus y plus pi h. All right. Does anything cancel? Yeah, the pi's all go. Okay, that's great. So the pi's all disappear. You can just divide both sides by pi. All right, great. Now at this point, we most likely are going to have to substitute because we have too many variables here. So for this big H, I'm going to use this one here. It will be 20 minus x, right? 20 minus x, like that. Plus x is equal to 9. H minus y. H minus y. I'm going to use this one. H minus y is going to be 28 minus h. if you just manipulate that one. And that's it. Okay, we are getting somewhere here, I think. So this one is 180 minus 9x plus x is equal to 252 minus 9h plus h. So 252 minus 180 is 72. Let's see here. This becomes minus 8x. This over here is minus 8h. Bring it over and it becomes 8h like this. Factor out an 8 and you'll get x minus h is equal to 9. Okay, x minus h is equal to 9. And therefore, h minus 9 is equal to x. And what I can then do at this point is substitute this into this one right here. And I hope that helps us. So 20 is equal to h plus x. And therefore, h is equal 20 is equal to h plus h minus 9. And therefore, h plus h is equal to 29. All right, great. And that, if you remember, was what they wanted us to figure out. Find big H plus little h. Big H right here plus little h. And we did that. We got it to be 29. So the answer to number 24 is A. A sequence T1, T2, ... Tn is defined as follows. T1 is equal to 14. Tk is equal to 24 minus 5. Tk minus 1 for k greater than or equal to 2. For every positive integer n, Tn can be expressed as Tn equals p times q to the n plus r, where p, q, and r are constants. The value of p plus q plus r is. All right, so first let's try to understand this question. They're saying that t to the n is equal to p times q to the power of n plus r. Okay, that's our big relationship right there. And then they tell us that t to the n is equal to 24 minus 5t to the n minus 1. Well, they're using k's, but just keep it consistent. N, k, same thing. So let's first look at this one here. If t is 1, we'd have p times q to the power of 1 plus r. If t is 2, we'd have p times q to the power of 2 plus r. If n is 3, t3, we'd have p times q to the power of 3 plus r. So you get the point, right? t1, t2, t3, you just plug in 1, 2, and 3 where the n is right here. Now let's turn our attention to this guy right here, t to the n. T to the 1 they've given us as 14. That's given right here. So we'll figure out t2, t3. And let's see what we get. So t2 is going to be 24 minus 5 times t1, like that. So 24 minus 5 times 14. And therefore this is 24 minus 70, which is equal to minus 46. All right, that's t2. Now let's figure out t3. So t3 is going to be 24 minus 5 times t2. So 24 minus 5 times t2 is minus 46. And therefore 24 minus 5 times 46 is what, 230? Yeah, about approximately 230 plus 230. So this looks like 254 for T3. Okay? So far, I hope there's no confusion here. I just figured out T1, 2, and 3. Okay, so the good news is we've got some integer values for T1 where's T2? T2 is right here. It was negative 46. And T3 is 254. Okay? And we know that T1 on this side is equal to PQ plus R. T2 is PQR squared. And T3 is PQ to the third plus R, like that. And I think at this point you kind of know what's going to happen. We're going to set these equal to each other, like that. And we will try to solve for P, Q, and R. And I think we can because we have 3 equations, 3 variables, and that is usually the recipe. So let's go with T1. We got T1 is 14, and that is equal to P times Q plus R. The next one is T2, which is minus 46, is equal to P times Q squared plus R. And finally, we have 254 is equal to P times Q to the power 3 plus R. All right, not as straightforward as you know, normally, you know, they just have X, Y's and all that stuff. We got some exponents in there, but that's okay. We can still do this with a little bit of fancy manipulation. So I'll call this 1, I'll call this 2, and I'll call this one 3, the equations. So the first thing I saw is that I can probably get rid of these R's pretty quickly. Anyway, like 2 minus 1, that would get rid of the R's. So if I did 2 minus 1, I'd have minus 46 minus 14. And on the other side, I'd have PQ squared plus R minus PQ minus R. So this becomes minus 60. And this becomes PQ squared minus PQ. And the R's do indeed disappear. So that's good. And this becomes minus 60. If you factor out a PQ, this will give you just Q minus 1, like that. And I think that's about as far as we can go there. And we can do something very similar with 3 and 2, 3 minus 2. That would be beneficial. So we have 254 minus 46. And that would be PQ to the power of 3 plus R minus PQ squared minus R, like that. So this becomes 300. And the R's cancel. So that would be PQ to the power of 3 minus PQ squared. And in a very similar way, factor out PQ squared. And this would be Q minus 1. Okay? So these two now, we can use this equation and this equation to solve for at least one of these variables. And I look at them and they look very familiar, or very similar, I should say. Not familiar. I haven't seen them in the past. But if I divide one by one, I think I should be able to isolate a variable. So if I make the numerator this guy right here, so on both sides, and then divide by this equation, you will see that you can isolate for one variable. So the left side just becomes negative 5, but watch, this cancels, that cancels, the p's cancel, and you're just left with q. So there you go. We've got q is equal to negative 5. So that's good. Now we can solve for p. We can just put it back into here, or anywhere really. So if I put q equals negative 5 into there, let's see what I will get. Minus 60 is equal to minus 5p minus 5 minus 1. So minus 60 is equal to minus 5p times minus 6. So that's 30p is equal to minus 60, and therefore p is equal to negative 2. Great. And then I think I have just one variable remaining, right? R. So I can use any of these equations that I got up here. This one seems simple enough. 14 is equal to PQ plus R. All right, let's use that one. So 14 is equal to P times q plus r. So 14 is equal to minus 2 times minus 5 plus r. 14 is equal to 10 plus r, and therefore r is equal to 4. And there you have it. And they wanted us to figure out what is value of p plus q plus r. P plus q plus r, all right? So p is negative 2, q is negative 5, and r is 4. This is p plus q plus r. And therefore that looks like minus 7 plus 4, which is minus 3. So minus 3 is our answer. Let's see if that's one of the answer choices. And it is choice B. I'm going to solve number 24 next, and the number of the question might be different, but the question is essentially the same. The circle with center A has radius 3 and is tangent to both the positive x-axis and positive y-axis as shown. Also, the circle with center B has radius 1 and is tangent to both the positive x-axis and the circle with center A. The line L is tangent to both circles. The y-intercept of line L is. So let's label this diagram first. First thing I'm going to do is drop a perpendicular from A down to the bottom like that, and the same with B. And then I'll draw lines to the sides, and these all of course represent the radius, like that, and like that. And one continuous line to the very end right there. And I think that should be enough. And if we need any more lines later, we can always add them. Now let's label the distances, what we know. We know that the radius of the large circle is 3. And therefore this is 3, and that's 3. And this is 3, and so on. They're all radii. The radius of the small circle is 1, so this is 1, and this is 1, and this is 1 right here, and this is 1 right there. Now this distance here we don't know, so I'll call it A. And this distance here similarly I don't know, so I'll call that B. And there's one more distance I don't know, and that's this guy right here, this little guy right there. So I'll call that X. I'll label X right there. Okay? So let's work with this. Let's see what we can find. Now the first thing I notice is that we have a similar triangle relationship. We have this triangle, and that triangle is similar to this one, this little one right here. All right? So because those triangles are similar, the ratio of the sides are the same. So in the first one, we've got 3, which is the height, and the hypotenuse, which is 3 plus 1 plus 1 plus x, right? From here to here is 3, then we got 1 plus 1, and then finally that little x there. And then that is equal to the ratio of the height and hypotenuse of the little guy. So 1 over 1 plus x. So 1 over 1 plus x, like that. So let's solve for x now. Cross multiply. We get 3 plus 3x is equal to, this looks like 3 plus 1 plus 1 plus x. So 3 plus 3x is equal to 5 plus x. And if you bring the x over, it becomes 2x, and bring the 3 over, it becomes 2, and therefore x is equal to 1. So there you go. We've got our first value. Now we will proceed with trying to find a and b. So let's try to find B first. B is very similar in terms of the similar triangle situation. Again, we're going to use the same triangles, this one and that little guy right there, that one. So we can use very similar relationship. We'll use the relationship of the side and the base. So for the big one, it's 3 over a plus b, like that. 3 over a plus b. And for the small one, it's 1 over b. 1 over b, like that. Okay? So cross multiply, you get 3b is equal to a plus b, and therefore 2b is equal to a. Now b we can easily figure out from this triangle right here using Pythagoras. Right there, that's a right triangle. Because remember, when a circle is tangent, it means that will become a right angle like that. Same thing's true there. So b, if you use Pythagoras, you get 1 squared plus b squared is equal to this hypotenuse, which is 1 plus 1, because we figured out the value for x. So we have 1 squared plus b squared is equal to 1 plus 1 squared. And this is 1 plus b squared is equal to 4, 2 squared. And therefore b squared is equal to 4 minus 1. B squared is equal to 3. So b is equal to root 3. So I can label that in there, root 3. And then coming back to this equation, 2b is equal to a. B we just figured out was root 3. So therefore a is equal to 2 root 3. All right? So far so good. Now what I want to do is blow this up as big as I can and explain something to you. So far what did we have? We have b is equal to root 3, which is right here, right? And this is 1 from here to here. And this, if you can bring that x in there, is 1 plus 1, which is 2. So we have root 3 as the base, 1 as the height, 2 as the hypotenuse. So if you remember, if you have any triangle that has those relationships, I'll draw a triangle here. So if you have a triangle that has those sides, 1, root 3, and 2, this is a 60, 30, 90 triangle, where this is 30 degrees and this is 60 degrees. This is always true. The ratio of the sides is always going to be 1, 2, and root 3. Not necessarily the side lengths, but the ratio for sure. In this our example, we happen to have the side lengths also equal to 1, 2, and root 3. But the ratio is always going to be 1, 2, and root 3 for any triangle that has angles 30, 60, 90. So therefore, this angle in here is 30 degrees, right there. And therefore, this angle also is going to be 30 degrees. Why? Because these two triangles, this one here and that one there, are identical. They have the same side lengths, they have the same angles. So that is also 30 degrees. Running out of space here. I'll just squeeze it in there, 30 like that. So that means this whole angle, right here, this whole angle is 60 degrees. Okay? So that basically means that you have another 30, 60, 90 triangle. That angle is 60. This angle, of course, is a 90. And by subtraction, you will get that that is 30. Okay? So, what do we want to figure out in our question? We want to figure out the y-intercept of line L. So right here, this is the point. It's a y-intercept, so it will be of the form 0, y. And y basically represents the distance all the way down to the origin like that. So that is y. Now how do we figure out y? Well, we have a 30, 60, 90 triangle, correct? And we can use the ratio of the sides. So I'll draw it here without messing up the diagram again. So we have this triangle, and it has the angles 90, 60, and 30. And y is right here. And this part, the base, we have figured out. It's 3 plus a plus b, correct? 3 plus a, which is 2 root 3, plus b, which is root 3. And this is all 3 plus 3 root 3. So now we can use the ratio of the sides, which in a 30, 60, 90 triangle are 1, root 3, and 2. All right? So let's calculate that. So that means that y over the base, which is 3 plus 3 root 3, is equal to the ratios, which is root 3 over 1. So let's solve for this. So this becomes y is equal to root 3 times 3 plus 3 root 3. And this looks like 3 root 3 plus 3 times root 3, which becomes 3 times 3, which is 9. So there you have it. 3 root 3 plus 9. And that would be choice E. A square array of dots with 10 rows and 10 columns is given. Each dot is colored either blue or red. Whenever two dots of the same color are adjacent in the same row or column, they are joined by a line segment of the same color as the dots. If they are adjacent but of different colors, they are then joined by a green line segment. In total, there are 52 dots. There are 2 red dots at the corners with an additional 16 red dots on the edges of the array. The remainder of the dots are inside the array. There are 98 green line segments. The number of blue line segments is... Whew. All right, we first need to understand this question. So I'll explain the question first, and then we'll try to solve it. Okay, so we've got dots, right? We've got dots that are either blue or red. There's only 2 types of dots, okay? So you got blue dots, like that, and you've got red dots, okay, like that. And then whenever 2 dots of the same color are adjacent in the same row or column, they are joined by a line segment of the same color as the dots. So what that means is that if you have 2 dots, let's say like this, blue and blue, it's so small, I probably prefer to draw it here. Let's say you have 2 dots, they're the same color. They're joined by a line of the same color, okay? And similarly, if you have 2 dots that are red, they'd be joined by a red line, like that, on that array, on that grid. But what if you have 2 dots that are different color? You have a blue dot and you have a red dot. Then it would be joined by a green line segment, like that. And that's what they're saying. Whenever 2 dots of the same color are adjacent in the same row or column, they are joined by a line segment of the same color. All right? Right there. If they are adjacent but of different colors, then they are joined by a green line segment. Okay, so far so good. Let's exaggerate this a bit. Blue, red, okay? Green line segment. Now let's keep going here. In total, there are 52 red dots. Okay, so on this grid, we got 52 red dots. Okay? And I'll write that over here, 52 red dots. There are 2 dots at corners. So at 2 of these corners, there's red. So 2 corners. And then additional 16 dots at the edges. So these are the edges, all right? These are the edges So we got 16 at the edges. And I'm assuming and that's exactly what it says. The remainder of the dots are inside the array. So 52 minus 2 minus 16 is 34. So 34 in the interior. Inside the array, interior. You know what? Let's just say inside. I don't want to introduce new terms. We've got enough to worry about in this question. And finally, there are 98 green line segments. So there are 98 of these guys. All right. How many blue line segments? They want you to find how many of these. All right. So hopefully that is a little bit of a explanation. Okay. Now let's start talking about the line segments. How many, first of all, line segments are there? We are told we want to find that how many blue line segments, and they've given us that there's 98 green line segments, and somehow, some way we have to figure out the number of red line segments also, right? But what is the total? The total, green plus blue plus red. Well, look at the graph. It's actually pretty easy to figure out the total, right? I hope. Because you have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 on each of those rows, correct? And how many rows do you have? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. So 10 rows, and each has 9 line segments, so 90. Okay, I hope you understand that. There's another 9 right there, and so on. But those are just the ones going horizontal. I've also got to count the ones going top to bottom, vertical. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 that go top to bottom. But in each of these columns, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those columns. So again, 10 columns with each column producing 9 line segments. So another 90. So 90 that go horizontal and 90 that go vertical for a total of 180 line segments. 180 line segments, I'll draw it in black so that you understand, is the total of blue line segments plus red line segments plus green line segments. Okay? That is our mathematical formula. And the good news is that they've given us at least one of these, right? They've given us the value for G right here. It's 98. There are 98 green line segments. So 180 is equal to blue. Let's maintain our theme here. Maintain our colors theme. And plus 98. Okay? So that means that blue plus red is 180 minus 98, which is 82, correct? So far so good, right? I hope you're not lost. Okay. Here we go. So far everything is fine. Don't get overwhelmed. Don't get discouraged. Just take it slow and you'll be able to understand this. Okay, so here we go. Next part of the question, or next part of the explanation, I should say. Now I'm going to concentrate on this guy right here. This information, I should say. They are giving me some important clues. We got 2 at the corners, 6 red dots at the edges, and 34 inside. If you have a red dot at a corner, correct, it will be producing line segments like that. You can look at the graph. I hope that makes sense. If you got a red dot at the corner, it'll produce a line segment going that way and going that way. And that's exactly what I drew over here. Okay? So how many line segments? Well, there was one here and one here. There's 2. For each corner dot, there's 2. But I have 2 corners. So 2 corners, 2 red dots at the corners, and each of those produces 2 line segments. So the total will be 2 times 2, which is 4. Correct? All right. Now let's look at the edges. If you have a red dot at an edge, like this is an edge, right? How many line segments can emanate from it? Well, one going that way, one going that way, and one going down, like that. There'll be 3. So we'll have 1, 2, and 3. 3 line segments that can emerge from each red dot that's on an edge. But we have 16 of them, so 16 times 3 is 48 line segments. I'll write that in there, line segments. All right. Now let's look at the one inside. There's 34 of them inside, so somewhere like here, right? That's inside. And how many line segments can emerge from a red dot inside? One going up, one going down, one going right, and one going left. So there'll be 4 in that kind of form. So if we have a red dot like that, we'll have one going up, one going down, right, one going down, and one going left. So there'll be 4 line segments from each of the 34 inside red dots, and that is 136. So the total line segments, 4 plus 48 plus 136 is 188. Line segments. Okay? Emerging from the red dots. Correct? Now the arrangement is as follows. If you have a line segment that's emanating from a red dot, right? If you have any red dot and you've got a line segment coming out from it, what color is it going to be? Well, if it is connecting 2 red dots, it's going to be a red line segment. If it's connected to a blue dot, it will be a green line segment. So when you have a red dot and a line, that color can only be either red or green, that line segment. You cannot have a blue line segment emerging from a red dot. The only way you can get a blue line segment is if you have 2 blue dots. Correct? So these 188 line segments are either red or green. That's the only way. Well, the good news is we know the question tells us that 98 of them are green. So that means 188 minus 98 is how many red line segments we have. Right? Because we figured out that the total number is 188, and the question tells us that 98 of them are green. So therefore, 188 minus 98, which is 90. 90 red line segments. Okay? Well, that's it. We can now use this equation to figure out blue, because we know that there's 90 red line segments. But if you sub 90 into that equation, you get minus 8 for blue. Blue is, you can't have minus 8, right? So what happened here? This 90 is indeed correct, but we double counted. Why did we double count? And I'll explain that. Let's say you have a red dot here, right, on the grid. The grid is so small, it's hard for me to even show you. And you've got another red dot immediately below it. And you've got lines, segments emerging. Correct? Now watch. The top red dot, I'm going to draw a line segment going down. The bottom red dot, I'm going to draw a line segment going up. Look at that. That is the same line segment, but it will be counted twice. Do you see how there's two of them? And similarly, you are going to double count like that. That line segment is really just one line segment, but each dot produces it. So therefore, there's actually two that are being included in this total. So the actual number of unique red line segments is 90 divided by 2, like that, which is 45. Okay, so that's a pretty tricky part of the question. Okay, so now at this point we're pretty much done. We have 45 red, and now we can use this equation. We'll just do it right here. We got 82 is blue line segments from red and plus red line segments. So 82 is equal to B plus, we calculated 45, and therefore blue line segments is 82 minus 45, which is equal to 37. So blue line segments is 37. The number of blue line segments is B for question number 25.